Hi everyone, today we're exploring OpenCode, an open source AI coding agent designed to help you build custom tools faster. I have two key questions. First, is it possible to create a simple app using OpenCode and a local AI model like Gemma-4 tailored for everyday research, say a tool that retrieves biomedical literature? And second, for a relatively straightforward task like this, is there a significant difference between running everything locally versus using a frontier model through a proprietary desktop coding app? Why should we care about cloud-based AI services? In many research fields, uploading data to the cloud is simply not an option because of strict confidentiality requirements. While there's nothing confidential about building a biomedical literature retrieval app, we'll use it as a test case to explore what can be accomplished with a local coding app and a locally hosted large language model. To get started, we'll install Ollama, download a local AI model, and then set up OpenCode. There are, of course, many ways to install and use these tools. You could work entirely from the terminal, write detailed markdown instruction files, and build a sophisticated coding workflow. But for this demonstration, we'll keep things simple and follow the easiest path. Then, we'll build a similar biomedical literature retrieval app using the OpenAI Codex app and the Soul Model 5.6. This isn't intended to be a rigorous head-to-head comparison. Instead, it's a practical way to develop an intuition for when a proprietary AI service is worth using and what can already be achieved with an open source, locally running system. So, what do we need for our agentic coding experiment? First, we'll install Ollama, which allows us to download and run AI models locally. For this demonstration, we'll use the recently released Gemma-4 model, which has received strong feedback from the AI community. Finally, we'll install OpenCode, which will serve as our local coding agent throughout the experiment. For our test, we'll also need Conda, a package and environment manager that lets you install Python libraries into isolated virtual environments, avoiding conflicts with your OS or other projects. For today's setup, we'll use Miniconda, which gives us all the functionality we need without the overhead. And for hardware, nothing fancy, just a simple machine like a MacBook Air with 24 GB of unified memory. If you don't already have Ollama installed, the easiest option is to download the desktop application. It's available for Windows, Mac OS, and Linux. Next, we'll download a model. For this demonstration, I've been using Gemma-4, either the 12 billion or the 26 billion parameter version. You can find Gemma-4 directly on the Ollama website, where you'll also find the commands needed to download it. Once Ollama is installed, you can download models either through the desktop interface or from the terminal. Both approaches work, but I prefer using the terminal. The download command is also shown here. When Ollama is running, you'll typically see a small Ollama icon in your system's menu bar or notification area. The desktop window itself doesn't need to remain open. In fact, for today's experiment, the Ollama service should be running in the background while the interface window is closed. As long as you can see the Ollama icon, you're ready to continue. Now, a quick note on context window. Think of it as the total amount of information, measured in tokens, that a model can see and process at once. In agentic coding, this isn't just about your prompt. It includes the files you're editing, the project structure, tool outputs, and everything else the agent needs to reason about. Tools like Ollama often default to a modest context window. While that's perfect for casual chat, it's usually too limited for complex, multi-step workflows. That's why we generally aim to expand the context window so the agent has the full picture to work with. Here's a simple way to create a derived Gemma-4 model using Ollama with an extended context window. It's also useful to install Conda to work in isolated virtual environments, keeping new Python packages separate from your operating system and other projects. That said, this gives you environment isolation, not a full sandbox. And now we can install OpenCode. The easiest way is the desktop app. Once this is done, we can create a folder to serve as our app development workspace. Here we have a simplified overview of OpenCode. As the user, you write a prompt with questions or instructions to generate some code. OpenCode then operates in two modes: a plan mode where an agent helps you break down the task into clear, actionable steps, and a build mode where the agent writes tests and runs the code, turning your prompt into a working tool. Through the OpenCode interface, you can interact with either cloud-based models using, for instance, the OpenCode Zen set of models, or run local models using Ollama. Overall, OpenCode orchestrates the loop between you, the selected model provider, and the tools until the task is complete. To start OpenCode on a Mac, simply double-click the small app icon. You'll see the interface with a chat window, a default project icon, and a small panel with 3 squares and a plus sign that you can click to see different projects and get access to settings. By default, OpenCode Zen is running with the selected model BigPickle, but other models can be proposed in the coming weeks or months. We can now select the workspace folder we just created. Now we can click the small icon and go to Settings. You can leave most parameters at their defaults, but I recommend enabling a few key features for better visibility and control. Reasoning summaries could be on to see how OpenCode and the model think through each step. You can choose a custom theme color, and you can turn on file tree, command palette, and server status. Most importantly, turn on the Show Agent feature. This is critical because, by default, the new OpenCode app launches in build mode. But when you're actively coding or prototyping, you'll likely need to be in plan mode first, where the agent helps you break down tasks before generating code in build mode. Next step, we will select the model provider. This can be done as shown on the screen or via the settings screen. Here you see many possible model providers, and we will select the custom OpenAI compatible provider option. Now we need to answer a few questions and fill out the form, enter the provider ID, the Ollama URL, and the exact model name you want to use, just as shown on screen. In some cases, you may need to close and reopen OpenCode. Next, we go back to our selected working folder, and we select the plan mode. At this stage, we can quickly test the connection. Just ask OpenCode what model it's using. If everything's working, you'll see the name of your local model right in the chat. If everything's working, you can begin planning your app. Just describe what you need. Where are the sources you want to connect to fetch scientific abstracts? Do you want to create a new Conda environment to install Python packages? Do you need specific data visualization diagrams and so on? This typically takes a few iterations with the planning agent, who helps break down the task into manageable steps before you move on to building. From time to time, you can check how much of the context window is being used, especially if the conversation is long. If it fills up, you can either compress the data or start a fresh session. Since we're using a local model, there's no cost, no subscription, no hidden fees. After 5 minutes of planning, once I was happy with the roadmap, in my case a literature retrieval app, I switched to build mode. It took about 10 minutes to generate the first version of my Streamlit app. Here's a screenshot of the result. The app searches across multiple repositories using keywords, with flexible logic like or to combine queries. The tool fetches the most recent studies, for instance, from the past 3 weeks and automatically removes duplicates, ensuring each article is counted only once, even if it appears in several repositories. In this example, I used just 3 repositories, highlighted in red on screen. Here's a screenshot of the data visualization diagrams, complete with interactive animations that trigger when you hover over them, along with a table showing the article titles and authors. Finally, we have the table with article abstracts and direct links to the papers. Next, I rebuilt a literature retrieval app using the OpenAI Codex desktop tool with the Sol Model 5.6 tuned to medium intelligence. Here's the result, a screenshot of the Streamlit app. The design is eventually better, But remember, you can add many design instructions in OpenCode. It took about 10 minutes to generate the code. Here we see some additional diagrams. Below, though not shown here, is the table with article titles and authors, though the abstracts are missing. Like in the OpenCode case, several rounds of iteration would be needed to fully refine the app. The takeaway? For this type of simple tool, neither a frontier model nor a proprietary coding tool is necessary. Consider this: if you're building a confidential app, say one that processes patient data, local open source models and tools could work just as well. Again, this isn't an exhaustive comparison, and the tool remains relatively simple. But it's a strong signal. You don't always need the most powerful model to solve everyday research problems. Here's the bottom line: you don't need the most powerful model to solve most research problems. With OpenCode and Ollama and Gemma-4, some other local models, you can build custom tools right on your machine. No cloud lock-in, no hidden costs. In sensitive fields like biomedicine, running models locally keeps your data and your ideas where they belong. As your work grows, you can scale by breaking tasks into steps or bring in cloud power when needed. But be aware of privacy trade-offs. And for advanced coding, proprietary systems can definitively help. But again, expect a privacy trade-off. This is it for today. I hope this simple intro to OpenCode will be valuable for your projects. Until next time, take care.